Welcome, thanks for joining. This is my first Twitch streaming with Manny. I hope you will enjoy it. Today I'm gonna talk about how Springboot integrate well with Kubernetes. So we're gonna look at how basically out of the box a Springboot application can be naturally deployed on a Kubernetes environment. We'll go step by step. It will be a hands-on session, so I will do live coding all the time. Starting from a Spring Boot application, we'll see how to Dockerize it, so how to package it as a container. We're gonna deploy it on Docker and finally on a Kubernetes cluster. So we're gonna look at different things like configuration, service discovery, liveness and readiness probes, and also some tips about how to establish your local development workflow when you work with Kubernetes. At any point, just write questions in the chat and I'll do my best to answer them. About me, I'm the author of the book Cloud Native Spring in Action that is available in early access on the Manning website. And here is a discount code if you're interested. Having said that, let's get started right away. I'm gonna code in IntelliJ. So the starting point for any Spring project is start.spring.io, of course. And here I'm gonna select the Gradle project, the latest production ready version of Springboot. I'm gonna set some parameters here. We're gonna build a demo service application. I'm gonna use Java 11, and as dependency I'll pick reactive web, then actuator, Lombok, and the configuration processor. So the reactive web dependency contains all the libraries to build a reactive web application. In particular, we're interested in exposing a REST API, and by default we get a NADI server. Springboot actuator is very, very useful in production because it exposes a lot of different information. So it gives us a lot of visibility into what is happening inside the application. Lombok is is a convenient library to reduce some boilerplate code, like to establish getters, setters, and constructors. And finally, the Spring configuration processor that we're gonna use on the IDE just as a convenient way of generating metadata. That's it. I'm gonna generate the project. Yes, and I'm gonna open it up in IntelliJ. So the actual content of a Spring Boot application doesn't change the capability of being deployed on Kubernetes, so we're gonna do something simple. Let's give it a second to build the project. Okay, so enter various. Yes. So locally, I'm using SDK Man. It's a very convenient tool that I recommend to manage different Java versions. You can install it on Mac, Linux, and also Windows. You can select different OpenJDK versions from different vendors, and you can have different versions of the JDK. It's very convenient if you're working on maybe testing compatibility with Java 11 or 15. It's a very seamless experience. That's what I'm using. Let's double check. Yeah, exactly. So I want to use Java 11. And this is just a standard Spring Boot application. We get the auto-generated files in the starter project. We have the entry point to the application. We have a property file. I will change it to YAML because I usually prefer working with YAML. So I'm gonna rename it to application YAML. Yes. And then a test just to verify that the context is loaded correctly. All right. So the first thing that we're going to do is defining a custom property. It will help us demonstrating different configuration scenarios, both in Docker and in Kubernetes. So what I'm going to do is creating a configuration bin. I'll call it demo properties. And in Springboot, we can use the annotation configuration properties. This will define this bin as a configuration. And in order for the framework to actually be aware of this bin, I have to annotate the application to scan the configuration properties. And there's an annotation for that. I have to define a prefix, so all the configuration properties starting with this prefix will be serialized into this bin. It will contain only one property. Let's call it message. And here I'm going to use Lombok to generate getters, setters, and constructors. Now, a nice thing about the last dependency that I added to the project, the configuration processor, is that it can generate metadata for custom properties automatically. So if I add a comment here saying, for example, a welcome message to the user, and then I build the project from Gradle, what happens is that the IDE will help me using these custom properties, just like any other properties. And there's something happening here. Sorry about that. Yes. All right. So now I can use my property. So with this prefix, the final property will be called demo.message. So I can go and say demo, and this is YAML, of course, message. This will be maybe welcome to Springboot. All right. Yes. Next, let's define a REST endpoint that we can use to do a test on Kubernetes. I can use here a traditional REST controller, but I can also go with a different approach that is now available both for Spring MVC and Spring Web Flux that is relying on some functional endpoints instead of REST controllers. So what I'm going to do now is defining a bin here. That will return a router function of server response. And here I can say return route, and then I can define a get endpoint. A get on the root, so just slash, and then in here I can use a lambda to return something. And since we are using Spring Reactive, this is gonna be a reactive object, so it can be either mono or flux. In this case, it's just a single value because we want to return the message, so I'm gonna use the mono. And this is server response dot OK. Now in the body, we want to use the property that we have defined in the bin. So I'm gonna do this. I'm gonna inject the properties bin and define a mono with just this value. Dot get message. and this contains a type of string. What's the issue here? Oh no, this is oh, that's why. Come on, okay. Router functions dot route. Okay, and then get, and we have request, yes, and build. All right. So this is it. Simple application will return a message that we define through a custom property. So we can directly run it. By default, it will run on port 8080. So let's see. I'm gonna go with the boot run. So the boot run task is building the application as a jar artifact. That's one of the nice things about Spring Boot. That jar artifact can run everywhere as long as you have a JVM, and that's the starting point to build a Docker image. This is the application running. And let's see if it's working. 8080. Here it is. Welcome to Spring Boot. Here I'm using a little tool that is called HTTPy. If you're interested, it's very convenient. I prefer it compared to curl because, yeah, it's much more intuitive. So I recommend you give it a try if you use very often the command line. Yes. So one last thing before we move on to containerize the application that I want to show is that whenever we build the application, we get a jar file that for Gradle is under build libs. So instead of using the boot run task, I could directly run the jar file from here, pointing to that path, build libs, and then the jar. And that's it. So from this point on, so we have a very simple Spring Boot application. It could actually be complex. It doesn't matter what you have inside, because the next step, it doesn't involve changing anything in your code. Containerizing a Spring Boot application since version 2.3 is actually very, very simple. You don't need to create a Docker file. You don't need to import any external plugin, but directly in your Spring Boot plugin for Gradle or Maven, so the one that you are already using to build your application, you can also build a Docker image. No Docker file, no extra files. And in in Gradle is called boot build image. There's a similar task in Maven, same functionality. And by default, this task will generate an image that is called like the project, in this case, demo service. But we can customize it. Usually it's better. So in Gradle, it's going to be in build.gradle, but in Maven, you're going to do this in the pom.xml file. At least two things that you would probably want to do is defining the image name. And since I want to push this image to my Docker Hub repository, I'm going to use my username on Docker Hub. That is also my repository name. And then instead of hard coding the name of the application and the version, I'm going to use the variable substitution in Gradle. So I'm going to use the project.name, that is the demo service, column, and then demo.version. Not demo, sorry, project.version. That is the version defined up here. The next thing I'd like to do is to be explicit about which version of the JDK I want to use. In this case, I'm using Java 11. So I can define that by passing some environment variables here. This means that I'm getting the last Java 11 version. Let's run it, and then I explain the syntax. What does this mean? First, I'll stop the application that is running a jar file. I'll start the task. And while that is running, I'll explain what is happening under the hood. So I'll go to buildpacks.io. This is the tool that is implemented inside the Springboot plugin for Gradle and Maven. This is a specification. This project is part of the Cloud Native Foundation. And Spring is using an implementation that is called Paketo. This buildpack specification works in a way that it detects what are you using in your project, and then it maps what you're using with existing recipes to build images. So in the case of Springboot, it will detect that is a Gradle project first, and also that is using Springboot. So it will use a builder image that contains these structures to build a good Docker image around Springboot. The implementation is Paketo. If you're interested, you can find in the Paketo buildpacks documentation all the configuration properties that you can specify. So like this environment variable here is specified there. BP stands for buildpacks. Yes, the task run correctly. Let's have a look. So the image that has been built is named like this. Docker.io is the registry name that is prefixed for all images on Docker Hub, and then the name that is specified. You can see, if you're interested, all the steps and all the things that this builder is providing is not just the jar file and the JVM, but is providing several different utilities like certificate configuration. And one thing that I like is the memory calculator. So it computes at runtime, depending on the deployment environment, it computes how much memory to configure for the JVM to run. And now I can take this image and push it to my Docker registry if I want to. Now I'm doing this manually, but actually this task has also a possibility to specify the configuration for pushing the image for you directly. You can do that by using this configuration. and then you specify a username and a password and the URL for the registry. Now, this is called password, but I really recommend not to use a password. So if you're using Docker Hub, but also for other registry, you can generate a token, a single purpose token that you can control better than the password. You should never expose your password or put your password anywhere. So this one is your username, but instead of the password, just use a token. If you're using Docker Hub, you can find instructions in your profile settings about how to generate a token. And then the URL that, in the case of Docker, would be docker.io. Once you have this configuration, and I'm getting some parentheses issues. So let's write something. So this is the username, this is the token. Once you have this, you can still run the same task, but when you want to also push the image, you can run put build image, and then you specify also a parameter that is publish image. Yes. So we have a Docker image. Before moving on to Kubernetes, let's see first if it works. I'll remove this because I'm not going to use it. And I'll use a Docker compose file to do that. This is called demo service. And the image name is shown here. Yes, you can define container name, demo service, and let's publish ports. Let's keep 8080 8080. Okay. Let's see if it works. And it failed. All right, let's see what's happening there. Okay. Let's do like this. Some cache issues with IntelliJ probably. Yes, here we have it. So first of all, I can check the logs in demo service. So you can see here how it's calculating the JVM memory based on my on the resource available on my computer. Let's see when it's starting. So it will first run some pre-configuration for the JVM, and then we'll start the application. At this point, let's see if it's still working. Port 8080, root endpoint. Welcome to Springboot. Now, since we are running in a Docker container, we could actually override that application property. There's different ways to override configuration in Spring. Usually you have in your application YAML or property file some default values, and maybe it acts also as a specification of what is possible to configure, and then you override it with different ways. One way is to use environment variables. And we can do that directly in the Docker Compose file here. I can specify an environment variable to override the demo message property. The convention in Spring is that if you have a property like this, so it's demo.message, right? Environment variables are usually all uppercases. So we'll transform this property name into all uppercase letters, and then we convert the dots into underscores. So this property will become demo underscore message, all uppercases and with the underscore. And this can be equal to welcome to Springboot on Docker. All right. And finally, let's update the application. And it started correctly. So now we can go okay, now it started. So we can go, and now we should get the new value that we specified with the environment variable. Here it is. Welcome to Springboot on Docker. All right, that's perfect. Let's remove this. Compose down. So if we sum up what we have done so far, we wrote a simple Spring Boot application. There was nothing in there about where the application is deployed. The only thing that we did to containerize it and deploy it to a Docker environment was to use external commands. So with boot build image, we built an image, and then with the traditional Docker Compose or Docker CLI, we can start the container. So the application didn't change. And then we saw also a way to override properties through environment variables with Docker if we want to customize the configuration. Now the next step will be to transform this into something that can be deployed in Kubernetes. And you'll see that actually I will not change anything in the application at all. Everything will be either configuration or defining some Kubernetes related deployment scripts. But the application itself is the same. This is a great feature of Spring Boot. You get an application that can run everywhere without having to change anything. And depending on the environment, it adapts and exposes different functionality. You'll see how in Kubernetes, some functionality that are not available locally are actually present. Locally, I'm running a Kubernetes cluster with just one node. And to do that, I'm using kind. That is running a Kubernetes cluster on top of Docker. So you need Docker installed. Another option would be Minikube that runs on a virtual machine instead. So you can see that previously I started a cluster here. I can get the information, kube control, cluster info. And it's misspelled, of course. Here it is. Control plan and DNS. Okay. Let's close all these windows. We don't need that anymore. And we start by creating a folder that we'll use to define deployment scripts for Kubernetes. Yes. Just a second, I'll be right back. All right, let's start with Kubernetes. So we have a cluster deployed. What we need now is two deployment descriptors that we need in Kubernetes. We need a deployment descriptor that we can call deployment YAML, and we need a service YAML. So the deployment object, if you're not that familiar with Kubernetes, can be compared to what we did previously with the Docker Compose. But the point of view is different because here in Docker Compose, we are managing a container directly, and the target is a single machine. Instead, when we move to Kubernetes, we are not managing a single container anymore, but with the deployment resource, we are managing the whole deployment around that container. That includes maybe deploying different replicas of the container encapsulated in pods. That contains a controller for managing the replication. So if you define that you want 3 replicas for your application, then the controller will ensure that there are always 3 applications running. And then the deployment itself to control something like rolling upgrade or doing some rollback if something goes wrong. So all those kind of controls that we don't have by default here. We have something if we switch to Docker Swarm, but in the standard Docker we don't have that. So we change both the granularity and also the amount of functionality around the application itself. And now it's going to be a bunch of YAML here. For a deployment, we have apps v1. The kind, we said it's a deployment. We have some metadata. The name, that can be demo deployment. And let's define also a label that we call app demo. A label allows to group different Kubernetes resources together. So as we'll see, we can manage different kind of resources by using a label, so without having to know names or to group by names. In this case, demo is fine. And then we have the specification itself. Let's start by having only one replica. Selector match labels. This is the part related to the replication control. So it's selecting all the pods with this label. And based on that, we make sure that there's always one replica running. And then we have the template. This is the template for the pod that contains our Springboot container that we created before. We have the label that is the same because we want to group all those resources. The name, this is the demo service application, even demo app. And then we have the specification. It's a lot of YAML. The image is here. And then we expose the ports. So you can see how this part is quite similar to what we have in the Docker Compose. And that's actually this part that is at the same granularity level as the container that we define here. But now we have all around that also functionality about replication and deployment management. I think this is it. Guess we don't even need this. And then we have the service. By itself, a deployment is not exposed to any network. So with the service, we can expose the endpoints from our Spring Boot application to the outside. The skeleton of these YAML files are always the same. We have the mandatory ones like API version, kind, metadata, and spec. And in metadata, the name is mandatory. This will be the demo service, and then we can have a label. And then in the spec part, we define the type of the service. There are different types of services. In this case, cluster IP, that is also the default one. It means that the application is exposed to a network that is internal to the cluster. Then in the next step, we'll see how to actually forward that to our local computer. So this is a type cluster IP. Again, the selector, that's why it's important. It's targeting the pods that have the label up demo, like we used. And then we have the ports. We have the service port, so the one that we're going to use to access the service, and the container port that is called target port. We can use the same port in both places. That's it. So with these two files, I can now run them. So I'm going to use the kube control utility, and I want to create Kubernetes resources that are described in the files contained in this folder, K8s. That's it. They have been created. Now we can see another useful thing of having used the labels, because we can get all the Kubernetes resources that are labeled up equal demo. Here they are. So the first is the pod that contains the container. So this is the one that contains the Springboot application containerized. We can see that the container is still in creation. Then we have the service that is exposed through port 8080 over TCP. We have the deployment, so the general resource that groups all the others, and the replica set. The replica set is the one that makes sure that this number of replicas is there. Let's see if it's now ready. Not yet. Let's give it a second. By the way, I wrote these YAML files manually now just to show you all the different parts, but there are different ways both to auto-generate these files, but also to actually not having to write them using different tools. Usually it's different YAML files, but less verbose. As you can see, there's a lot of duplication, for example, with these labels, especially in the deployment file, that can help you. I won't be showing you that today, but if you're interested, just ping me, and yeah, I can share some resources. Okay, now the application is running. So I expect to have the same functionality as before, but now the application is running inside Kubernetes. The service is exposing the endpoints inside the cluster, and I need a way to expose it to the outside world. In an actual deployment environment, we're gonna have usually a load balancer doing that, some ingress controller handling the traffic in and out the cluster. In this case, we're working locally. We can use a convenient functionality of the kube control interface, and it's called port forward. And what we can do is forwarding the traffic from the internal service that is called demo service to our internal or local 8080 port. So the first port is the port on my local computer. The second port is the port exposed by the service inside the cluster. If I do this, I can see that now all the traffic is forwarding on my local computer, and I can finally call the application. Welcome to Springboot. Now in Docker, we use environment variables to configure the application, but with Kubernetes, we have more sophisticated ways to do that. For example, config maps and secrets. And starting from Springboot version 2.3, we actually have native support for that. So as you will see in a minute, I will not change anything in the application, but I will just rely on the Springboot native functionality. So what I need is a new file here that I'll call config. Again, we have the API version. Kind is config map. Metadata, name, demo config. And then we have the data. Inside here we have different options. We can have properties overwritten in the environment variable format, but for Spring we have actually a different way. We can import here either an application.properties file or an application.yaml, and I can embed it here. So just like I did inside my application, I can use the same format in a config map, but this time I will change the message, welcome to Springboot on Kubernetes. That's the first step. Once we have the config map, I have to mount the config map as a volume in the Springboot container, and I can do it in the deployment file. So first thing first, I'm gonna define a volume here. Config volume. And then I'll point to the config map. That I think I called config demo config. The volume is defined, and I can finally mount the volume to the demo service container. Now this is interesting. So if you're familiar with how Spring Boot manages properties, there's a hierarchy of places where Spring Boot looks for properties, and depending on the level of the hierarchy, then some properties can override others. You can find the full list in the Spring Boot documentation. You can see here a long list of places where Spring Boot is looking for properties. What we have normally inside the application is the application data like this. But another way that is available by default is the config folder available either in the same path where the jar file is located or in the parent folder. And you can probably find all the information here. But the important thing for us is that Cloud Native Build Packs that is available in the Spring Boot plugin builds an image and puts the jar file, inside a folder called workspace. So the jar file inside the image is in there We can even go and look. Inside there, we create a config folder. This is one of the default places where Spring Boot is looking for configuration. So we have to do nothing about it. Spring Boot will just detect that there's configuration available there. And now let's refresh. I will interrupt the forwarding. This command is deprecated. I shouldn't use this in this way, but it works. And then let's see all the resources. You can see also that one is terminating and another one is running. So this is the old one. The new one is started. Let's check if it's working. Oh yes, I forgot to forward the traffic. Yes, so once again, port forward. And here it is. Welcome to Springboot on Kubernetes. It works. And I didn't have to do anything. This is really great. Of course, you can configure it. You can find all the information in the documentation. Besides the generic information about externalized configuration in Spring Boot, you can look into the external application properties and in particular the configuration trees. That is what is using by Kubernetes. So you can find for config maps and secrets how to configure that. And as you saw, when I introduced this config map, Kubernetes terminated the existing pod and created a new one. And if I change only the configuration, for example, I can say welcome to Springboot on local Kubernetes. Yeah, maybe it's too late to show that. I was too slow. Yeah. And I forgot the forward, right? Yeah, there's something wrong. Anyway, what I was saying is that whenever there's new configuration, Kubernetes will restart the container by providing the new configuration. But if you don't like that and you want to have a refresh of the configuration without shutting down Spring Boot, you can do that by using Spring Cloud Kubernetes. One of the modules in this project lets you do exactly that. Yes, with this Kubernetes configuration watcher, it will send to this endpoint to your application a signal, and then Spring Boot will refresh only the beans that are affected by the property. So in this case, it would work if I used on probably this one, a refresh scope. I guess it's not included in the path. But there's a refresh scope annotation that you can use in order to refresh the application, and you can find all the information here. So the next thing I'd like to show is, again, something that has been introduced in Spring Boot 2.3, and is about Liveness and Readiness probes, and also Graceful Shutdown. So locally, whenever I shut down the application, it doesn't matter that it's actually shut down immediately. But in production, I don't want to do that because maybe the application is handling some request. So I want to wait for all the pending requests to be processed. Otherwise, I can't achieve the zero time deployment, zero downtime. So what I can do is relying on the Springboot actuator. So far we didn't use it, but the Springboot actuator is exposing different endpoints about the health of the application, about the environment configuration, about metrics. You can use it to expose metrics to be scraped by Prometheus, for example, and then show dashboards in Grafana. But there are in particular two things about the Graceful Shutdown that I want to show. I don't want to do it locally. I'll just do it to show the properties. But we have the server shutdown property that I can set to Graceful. And then there's another property that I have to define, that is the timeout for the Graceful period. This means that whenever a termination signal is sent to Springboot, the server will not shut down immediately, but it will wait up to 20 seconds in order to complete the handling of all the pending requests, and it stops accepting any new request. So both these properties are actually a good candidate for the config map that we have here, because we want it in a Kubernetes environment, but not necessarily when we develop locally. And this is enough. And then in Kubernetes, we can leverage the Springboot actuator and define the liveness and readiness probes. The liveness probe is an endpoint that tells Kubernetes if the application is live or not. And that means that if the application is not live, Kubernetes will try to restart it. So the liveness state means that the internal state of the application is so wrong that it cannot restore by itself. So it needs to be shut down. Instead, the readiness probe signals that the application is actually ready to accept a request. And Kubernetes uses these two things for two different goals. The liveness probe, to know if it has to restart the application because it's not working anymore, and the readiness probe to know when is the time to actually start sending requests to that application. Because if it's not ready, then Kubernetes will not send it any traffic because it's not ready to process requests. Let's do that. We are in the containers section of the deployment part. And we have a liveness probe. What we do is we access an endpoint that maybe I can show you first. This is enabled by Springboot only on Kubernetes automatically. Let's first check this endpoint. This is the generic health endpoint that contains different information, and on Kubernetes it contains also the liveness and readiness probes that I can access individually by appending this group name at the end. Now the application is correctly up and running, so both the liveness and readiness probes will be fine. So I can use this up here. So the HTTP GET for the liveness probe will be actuator/health/liveness, and I also have to specify a port. That is the same as the application in this case. And then I can define an initial delay in seconds, like 15, before Kubernetes should start checking the liveness state, and then maybe 5 seconds. So every 5 seconds it checks if the application is live. And the similar structure is for the readiness probe. Now, since it's a distributed system and Kubernetes itself is composed by different parts, sending a termination signal has some delay issues for which some requests could still be sent to the application even if the application already started a graceful shutdown. A workaround for that is also documented in the Springboot documentation is defining a pre-stop hook in the Kubernetes lifecycle for pods. And this could be as simple as just a wait. So we could use the shell command for sleeping 10 seconds. So Kubernetes will sleep for 10 seconds. In that time, the request can stop being sent to the application, and then we start with a graceful shutdown period. So we avoid errors. Yes. We probably won't see any effect at all if it works, but it's very important. So you can see this new pod is running, but it's not ready yet. So it means that it is live, but the readiness probe is not returning a 1. It's not returning an OK signal. It means that Spring is not ready to accept a request. Let's wait a second. It's not usually this slow, but my computer apparently it's really under stress right now, so it's slowing everything down. So it will probably need a bit more time. That's a pity. But in a normal situation, you would have just a few seconds here because Springboot is pretty fast starting up. So let's see. In the meantime, I like to talk about one more thing. When we deploy Springboot applications on Kubernetes, we can leverage the native functionality for service discovery and load balancing. So as you saw here, we can define replicas. So I could define 2 replicas, and then I would get automatically the traffic load balanced between the 2. And the same is true if I have multiple Springboot applications, like in a microservice architecture. I can directly send the request to the service name, the one defined here, and then Kubernetes will resolve it automatically. So we don't need anymore to use something like the Spring Cloud Netflix Eureka project to have a service registry in place and having to register all the application with the registry, or having to explicitly load balance the traffic. That is done by Kubernetes. It's one more thing that you get natively. Wow, it's really slowing down. I'm gonna need more RAM and CPU probably. Yes. So just to wrapping things up, while hopefully this works at some point. To recap, we haven't done anything in Springboot in order to make it possible to deploy it on Kubernetes. So any kind of Springboot application can be deployed both on Docker and Kubernetes. You can use the built-in functionality of the Springboot plugin for Gradle and Maven to build a Docker image out of a Springboot that is based on cloud-native build packs, in particular Paketo. After you have an image, you can deploy it to Kubernetes, and in Kubernetes you can access different native features like config maps, where you can define directly your application properties in a familiar format, either properties or YAML like this, and you can mount them as volumes. And Springboot automatically will find that configuration that will have, of course, higher priority than the one defined inside the application itself. I also talked about liveness and readiness probes. This functionality in Springboot is enabled by the Springboot actuator. That is usually something that you have in production because it's extremely useful for many different reasons. That is also exposed automatically. Springboot can detect when it's a Kubernetes environment. And remember this little hack, this workaround. It's a distributed system, so there is some delay in sending the termination request to all the different components in a Kubernetes cluster. Maybe not that much necessarily on a local cluster, but in a real production cluster, this is the recommended way to do it. And finally, if you'd like to work on a local Kubernetes cluster with Springboot, I don't recommend you do what I've been doing today, but there's a tool that is called Scaffold that you can use to establish a workflow locally. You can either start it with Scaffold init, or you can directly write a file by yourself. And I can show you. It's once again another YAML file. Same format, but this one is a bit different because it's a custom resource from Scaffold. You can generate this automatically, but I'm gonna do like this. So in here we can define, basically it's a description of what we have done so far inside Docker. We have inside Springboot. I define my image without the version, and then I want to build it with build packs. This is what Springboot is using under the hood. I'll probably misspelling something, of course. But you can recognize it's the same configuration that I wrote before in Gradle, and I will actually point to Gradle here, to the source folder where my project is, and to the build.gradle file. And finally, I point to the Kubernetes manifest. So now everything that is inside this folder will be managed by Scaffold. Scaffold will keep monitoring your project. Every time you change something, you will automatically deploy the project in there. Yeah, let's remove this so I can show you. Maybe we're lucky. And Control delete and Kubernetes All right, let's see if I misspelled something. You can just do scaffold dev, or you can even do scaffold debug if you want to open up the port to do remote debugging. I think it's really useful. And it can also do the port forwarding for you. Yes, of course. Line 5. This is nice because I can also show you that what I've been doing so far. You can find it on GitHub. I will tweet this URL. You can find all the information and also some extra information about service discovery and load balancing. So let's have a look at this. I probably misspelled something. Yeah, it will probably take a while. But this is really convenient if you want to run it locally. So this is it. If you want to explore more the Springboot capabilities in Kubernetes, you can find a lot of information on the Springboot documentation. In particular, I would look into the part about configuration. You can also find information about Actuator, and you can see here in the endpoints section, you can find all the health information and the Kubernetes probes. So it's all documented. And then if you're interested in having to access from within your Spring Boot application to the Kubernetes resources, then you can have a look at Spring Cloud Kubernetes. This project is not required if you want to run Spring Boot in Kubernetes, but if you need to access, for example, the list of all the services running in a Kubernetes cluster, or if you want to do like the configuration watcher that I mentioned before, or other interesting things, like if you want to do service discovery by yourself, you can use this project. So you would get a discovery client bin, you get the list of all the replicas for a specific application, and then you do load balancing by yourself, should you need to do that. But it's not needed. Yes, and this is it. I thank you very much. In my book, if you're interested in cloud native development with Spring and Kubernetes, I will talk more about this and also all the patterns and guidelines when working with cloud native, including different architecture patterns involving synchronous and asynchronous communication, several deployment related topics. This is a discount code if you need. And for any question, just tweet me. You can find me on Twitter, on LinkedIn, or on my website, thomasvitale.com. Thank you very much for joining. Thanks, Manning, for hosting. And see you next time. Bye.